Okay, so we have our first test tomorrow, and hopefully you are here to review and you understand everything for the test tomorrow. But just in case, I wanted to go over everything one more time. So on number one, we have all of these temperatures, and we need to put them in order from coldest to warmest. So that means we want least to greatest. Remember, if we were thinking of a number line, we would have 0 in the middle. Our negatives would be over to the left, and our positives would be over to the right. And so think about over on the negatives, I'd have -1, -2, -3, 4, 5. We'll say -6 is about right there, and then -7, -8, -9. -10.5 is going to be somewhere over here. Obviously, we talked about 0 already, and then 1, 2 would be right here, and then 3, 4, 5, 6, 7, 8, 9. Okay, so least to greatest, least is on the left, and so that means that -10.5 would be the smallest amount, then -6, then 0, then 2, and then 9. Remember that whether they give you a number line or not, you can always draw in your own number line. Question number 2 was sorting numbers as either rational, integer, or whole number. And so 6.7, oh, and I forgot to say, if you're looking for more info on this last one, that's on page 5. And this question number 2 is on page 3. So 6.7 would go under rational, because anything with a decimal or a fractional piece has to go under rational. -4 would be an integer because it is negative, but it does not have any fractions or decimals. The number 9 is a whole number because it's positive and it doesn't have any fractions or decimals. -1.3 is rational because even though it's negative, it has a decimal, so it has to go there. And then the last one, this is the one that's a little bit harder. So when we see a fraction, we think rational. But remember that if you see an improper fraction, you've got to divide it out and see what it actually equals. So this is 10 divided by 2. Well, 2 goes into 10 5 times with nothing left over. So that really is just the number 5, which is a whole number. If it was something like, let's say it was 11 over 2. Well, 2 goes into 11 5 times, but it has 1 left over. So 11 over 2 would be 5.5. That is a rational number. Okay. Question number 3. We have all of these times, and we want to know the order from least to greatest. So whenever you have fractions and decimals, you want to make them all look like decimals. So, and specifically money. So this one already looks like money. That's $1.95. If I had a 0 there, we're talking about -$2. If I had a 0 here, we're talking about $1.40. 1/2, remember half of $1 is 50 cents. So that's like 50 cents. And then 1/4 of $1 is like 25 cents. So this would be -$1.25. If you don't remember your benchmark fractions, then remember you can always do top in, bottom out. So for 1/4, I could divide 1 divided by 4. Well, 4 doesn't go into 1 because it's too big, but it goes into 10 2 times. 4 times 2 is 8. 10 minus 8 is 2. If you don't have anything to bring down, you can add another 0, bring that down. 4 goes into 25 times. So we still got the 0.25 there. That's just another way of figuring that out. So we're supposed to be going least to greatest. Just like on this problem up here, remember your negatives are always going to be the smallest ones. So the one that would be furthest on the number line to the left would be -2.0 or -$2. And then you only have one other negative, so -$1.25 would be next. And I accidentally wrote that as a decimal. Remember, that was really -1 1/4. Then we only have positives left. So 1/2 or 50 cents would come next. Then $1.40 or 1.4. And your biggest amount would be $1.95. So that is least to greatest for those numbers. And that is on page 9 of your notebook, page 9. Okay, coordinate graphing. You have info about this on page 6, but specifically with decimals and fractions, which this problem has. Sorry, I cannot get this in the right spot. That would be located on page 10 of your notebook. So if you notice right here, we've got 1 and we've got 2 right there. So remember that if you're thinking about money, between 0 and $1 is 50 cents, and between $1 and $2 would be $1.50. So think about this like money. It's going up by 50 cents each little line. So I'm going to skip point A because that was the toughest one. I'm going to do the other ones first. So for B, we go over to 1, so that's our x coordinate, and then we go up, and it's right here in between 1 and 2, so that's going to be 1.5 or like $1.50. For point C, we come over here to 0.5, and then we go down right here, which is negative 0.5. So 0.5, negative 0.5. Point D, we go over to the negatives. This is negative 1. Kind of hard to see, but that's negative 1. And then we go down to negative 0.5. Notice they both have the same x-coordinate because they both went down to the same spot. Point E, we go over right here in between negative 1 and negative 2, so that's negative 1.5. And then we go up here to 1.5. And notice that those two also had the same y-coordinate because they both went up to 1.5. So for point A, the reason I left it is because it's in the middle here. It's right here in the middle of 0 and negative 0.5. So that would actually be negative 0.25. And then it goes up all the way to 2. So those are the coordinates of all of those points. Let's see. The next question is also about coordinate graphing. It has the same coordinate plane, but this time we have to do the dots. So whenever you see fractions, you want them to be decimals. It's a lot easier to plot these as decimals. So remember that 1/2 is 0.5. And again, that's one that I really want you to know by memory, but if you don't know it by memory, just go ahead and work it out using Tybo, and it's 0.5. So again, 0.5 would be right here between 0 and 1 whole. So I go over to 0.5, and then negative 2 is way down here. So that's point A. This next one already has decimals. So I can go all the way over here to 1.5, and then up to positive 1. That's point B. Point C has 3 over 2. So again, we can just do Tybo. 3 goes inside, 2 stays out. 2 goes into 3 one time. Down my 0. 2 goes into 10 5 times. So 3 over 2 is the same thing as 1.5. So I go over here to 1.5, and then I go down to negative. Oh, sorry. I'm supposed to go over here to negative 1. Sorry, I was looking at the wrong number. Over here to negative 1, and then up to 1.5. Here we go. That's point C. So remember, it's always x first, then y. Okay, so for point D, negative 1.5 is just going to be negative 1.5 because we already said half is 0.5. So I go over here to negative 2, and then I go down to negative 1.5. So that right there is point D. Okay, next problem. Opposites and absolute value can be found on page 4. Okay, so the opposite of negative 1 is just positive 1. And we mark that in the griddable using the positive symbol and putting 1 in the ones place. This is the decimal point right here. So if you go after that, you're talking about tenths, and then hundredths, And so if your answer has tenths or hundredths, then of course you would want to put stuff there. If not, you either leave it blank or you can put in zeros there. Either way is fine. Remember that these lines right here mean absolute value. So absolute value is always positive, and so absolute value of -9 is just +9, and we would graph that right there. 2 more problems. So this first part is greatest to least, and so we would want to start with our positives, so 10, and then 7, and then 0. And then kind of picture crossing over to the negative side, you'd get to -8, and then all the way to the left would be -13. And again, you could draw out your own number line to help you with that. This next part is least to greatest. And we've got some fractions and some decimals. Remember, you want them all to be decimals, and the easiest thing is to make them look like money. So I can add a 0.00 there, and that's like $5. This one already looks like money. 1/2 is 0.5, so -2.5 would be like -$2.50. 2/5, if we do Tybo on that, it comes out to 0.4. So this is like -40 cents. And then we can also do Tybo on 21/4. So 4 can't go into 2, but it does go into 21 5 times. 4 goes into 10 2 times. Add a 0, bring it down. 4 goes into 25 times. So this is like $5.25. And so now if we're going least to greatest, we're going to want to start in the negatives, and that means that this one right here would be the smallest amount. It would be furthest to the left. Right next to that, very, very close to it, would be -2.47, and then -40 cents, or sorry, I did that again. That should be -2/5. And then we pass over into the positives. 5 would come next, and 21/4 would be the biggest amount because that is $5.25. Okay. Last problem, putting all of these on the number line. So we want to think of this as $24 and this as $25. And these lines in between, there's 10 sections, so that means it's going up by 10 cents every time. So this is $24.10, $24.20, 30 cents, 40 cents, 50 cents is in the middle, 60 cents, 70 cents, 80 cents, and 90 cents. I'm not going to write in all the 24s because that would just take too long. So 24.2 is like $24.20, so that would go there, 24.2. I'm going to skip to this one because 24.08, that looks like $24.08, which is going to be close to $24.10, so that's right about there. I'm going to do 24.5 next because that's like $24.50, 24.5. And then I left this one to last. Again, that is a benchmark. It's great if you know it, but if you don't, you can always do Tybo. 5's too big to go into 4, but it goes into 48 times. So this is like $24.80, because remember we can add a 0 on the end there, which would be right there, 24 4/5. And the question said which one is closest to 25, so it is that one because that one is the closest to 25. Okay, I hope that made sense. Please, please, please rewatch any parts of the video that you need to help you understand. Maybe get a parent or an older sibling or a friend to help you. Come see me in the morning if you need me to explain something again. And I hope you do well on tomorrow's test.